Good afternoon, 5th and 6th grade. It is time for your science video for Tuesday, November 3rd, Election Day. And we're going to be doing work text page 62. So if you have that out, you can look at page 62. And we're going to do the top part there, which talks about two different types of energy, kinetic and potential energy. And then it says to identify the type of energy present in each of these situations. And so they're going to give you several situations here. We'll be talking about that in your reading. And then at the bottom, energy is the ability blank. Some forms of energy include light blank, electricity blank, energy, and chemical energy. We'll get that, and I'll try to point them out as we get to them. Energy can be classified as blank energy or blank energy. I can tell you what those two are right there. Kinetic or potential energy are the two answers for number 10. All matter is made up of blank, blank, or blank and blank that are always in blank. Because the atoms and molecules are always moving, they have blank energy. It says the total kinetic energy of the particles in a substance is called, and it has a blank there, and then the thermal energy of a substance depends on its blank and blank of that substance. And then blank is the measure of the average kinetic energy of the particles in a substance. Now, when I say blank, that means that there's a blank there, in case you were wondering. That word blank doesn't go in the blank. And so we'll go ahead and start with your reading on page number 86. And so if you look there for page 86. All right, energy. Think about some of the things that you do each day. Maybe you have a refrigerator in your kitchen. You may have turned on a light. Hopefully you ate a good breakfast. Perhaps a car or bus took you to school. Someone adjusted the temperature in your classroom to make you comfortable or uncomfortable. While these are very different activities, they all involve energy. Energy is the ability to do work. Notice that first blank, 8. Energy is the ability blank to do work. Some forms of energy are light, sound, and electricity. The next blank there, light, sound, electricity. And then it says machines such as cars use a type of energy known as mechanical energy. So there's that fourth blank there, or third blank, second blank, whatever it was, the one that's missing. All right, and then it says that thermal energy causes your room to be the temperature it is. Even the food that you eat contains a form of energy. The food provides chemical energy for your body's needs. You can see the energy comes in many forms, but energy would not be very useful if it could not change from one form to another. A flashlight works because of converted energy. The chemical energy in a battery changes to electrical energy. This energy then causes the filament of the bulb to glow, releasing light energy. Scientists sometimes classify energy as potential energy or kinetic energy. That's the one I gave you the answers for. Potential or kinetic. Potential energy or stored energy is the energy that an object or substance has because of its position or condition. A roller coaster at the top of the track has potential energy. As the roller coaster starts down the track, some of its potential energy changes into kinetic energy. Kinetic energy is the energy that an object or substance has because of its motion. A flying jet and flowing water both have kinetic energy. They are both moving. All right, so that would help you on that first section there where it talks about whether something is potential or kinetic. You put a P or a K. And so for each one of those things, if it's moving, then you know it's kinetic energy. If it's not moving, then it is not kinetic energy. It is potential energy. All right, God is the creator of all matter and energy, but people use matter and energy as tools to meet their needs. Sometimes they change energy from one form to another. At other times, they use matter to produce energy. All right, page 87, thermal energy. All matter is made up of tiny particles called atoms and molecules. They are always in motion. This means they have kinetic energy. One kind of kinetic energy is thermal energy. Thermal energy is total kinetic energy of the particles in a substance. The thermal energy of a substance depends on the temperature and mass of that substance. As the temperature of a substance increases, the particles move faster. The faster particles move, the more thermal energy the substance has. For example, particles in a cup of hot water move faster than the particles in a cup of cold water do. Therefore, hot water has more thermal energy than the same amount of cold water does. The mass of a substance also affects the thermal energy of that substance. If two substances are the same temperature, the substance with the greater mass will have more thermal energy. More mass means that more particles are present and moving. The more particles that are moving, the more thermal energy a substance has. For example, a large pitcher of water at room temperature has more thermal energy than a small glass of water at room temperature does. All right, and so that would I guess a good example, another example might be if you have 1 cube of ice in a glass of water as opposed to a glass full of ice, that one that has the glass full of ice has less thermal energy, and so it takes longer for the ice to melt in the one that's full of ice as opposed to the one that is only 1 ice cube. All right, next page, temperature. We've done temperature for one of the assignments where you measured the temperature of the water in the cups, and that's what we're talking about here. When we talk about temperature, we usually mean how hot or cold something feels to us. On a summer day, you may feel hot. On a winter day, you may feel cold. Sometimes, even in the same conditions, one person may feel comfortable, another may feel cold, and still another may feel warm. Hot and cold are words that we use to describe how we feel, but they are not very accurate or useful for science experiments. Scientists need terms that have more exact meanings. One word scientists use in an exact way is temperature. Temperature is the measure of average kinetic energy of the particle in a substance. Particles are always moving. However, not all particles in a substance move at the same speed. Some particles move faster than average, and others move slower. So finding the average speed is more accurate than saying how hot or cold the substance feels. I guess one way to describe that, if you've ever been to in the water in a beach, let's say you're standing up to your waist in the water, and you'll feel sometimes like cold water will come by your legs, or hot water, or something that's warmer and it feels good come by your legs. You can kind of feel that in the pool as well. Usually it's because that they're pumping in some warm water to make the water warmer, and so you'll feel it. But that part of the water is warmer than the other part that's not warmer. Temperature is not the same as thermal energy. A substance with great mass has a lot of thermal energy. However, the average speed of its particles may be slow. The substance may still feel cold. In this case, it has a lot of thermal energy but a low temperature. How can temperature be measured exactly, though? Well, God designed your body to adjust to different temperatures. For this reason, you cannot measure temperature by how something feels. If you go swimming in a pool, the water may feel cold at first, but after a while, the water no longer feels cold to you. The water has not gotten warmer. Your body has adjusted to it. So, to get an accurate temperature measurement of temperature in an instrument that does not adapt to its surroundings must be used. A thermometer is an instrument that measures temperature. So I think that's one of your... Nope, doesn't look like it. So number 15 looked like one of those answers there. Blank is the measure of the average kinetic energy of the particles in a substance. And that is called what? What is it? Temperature, yes. So you see there are some students here watching me do this. They're my audience today. Temperature is usually measured in degrees Fahrenheit or degrees Celsius. Some people use the Fahrenheit scale. The nurse probably takes your temperature using the Fahrenheit scale. The weatherman usually tells the temperature outside using this scale. On the Fahrenheit scale, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. Scientists, however, usually use the Celsius scale to measure temperature. Celsius scale is based on the freezing point and boiling point of water. On the Celsius scale, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. What did we find out about yesterday, though, in that film video that we watched? That originally, when he designed the scale, that it was upside down. He had it the other way around. 100 was freezing and 0 was boiling. All right, so it says, meet the scientist, Lord Kelvin. Fahrenheit and Celsius are not the only scales used to measure temperature. The Kelvin scale was developed by William Thomson, born in 1824 in Belfast, Ireland. Thomson studied thermodynamics, the science of heat and energy. His temperature scale is based on the movement of molecules. Instead of degrees, his scale used kelvins. He placed 0 at the point where he believed molecules no longer move or have kinetic energy. Absolute 0, written as 0K on his scale, is equal to about negative 273 degrees Celsius. Thomson also had a great impact on communication technology. His inventions allowed the first telegraph cable to be laid across the Atlantic. In 1866, he was knighted by Queen Victoria of England. Later, his title became Lord Kelvin. Although Lord Kelvin was a highly honored scientist, he was also a humble Christian. He said, if you think strongly enough, you will be forced by science to the belief in God. He continued to study science until his death in 1907. All right, and so that is your reading for today. Hopefully that clears some things up for you and gives you some of the answers you have there. All right, and now I'm going to have the ending of the show, and that is There we go. Okay, so we're done. And that is your secret word, applause. All right. Have a good day. Bye.